Welcome back, everyone. So today in this lecture, we're going to cover the division algorithm. We're going to cover the factor theorem, and we're going to go over or review the quadratic formula. So last time we talked in class, we talked about long division and synthetic division of polynomials. And I encourage you to review that because it is a little bit different, even though somewhat familiar, but you need to get a good hand of doing long division and synthetic division. Now remember, long division can be done in any situation. However, with synthetic division, the equation must be given to you in this form, where the divisor, the one that you're dividing by, is x plus or minus a number, okay? So remember, if it is x plus or minus a. So if it's x minus a, you're going to divide by a using synthetic division. If it's x plus a, you're going to be dividing it by negative a. So let's do an example to remind you how we did this. So let's take, for example, x cubed minus 7x minus 6 divided by x plus 2. So because we have x plus 2, that means we're going to divide by actually negative 2. Now, in the top row, we're going to write the coefficients of my polynomial. So remember the criteria. Number one, that it must be in descending order of power. And number two, all powers must be represented. Okay, that simply means that if you have a fourth degree polynomial, you must have a coefficient for the third degree term, second degree term, first degree term, and constant. If you're lacking any of those, you just use the coefficient of 0. So let's look at this example. Checkpoint 4. We're dividing x plus 2 into x cubed minus 7x minus 6. So the first criteria is that it must be in descending order of power, which it is. Now, the second criteria is that it must have all powers represented. So because it is a third degree polynomial, that means that I must have a second degree term, a first degree term, and a constant. Well, if you look at it, I do not have a second degree term. So I'm going to rewrite this as x squared, x cubed, plus 0x squared minus 7x minus 6. Okay. Now, in the top row, I'm going to write my coefficients. So the leading coefficient is 1. The one that was missing, the x squared term, the coefficient is 0, negative 7, 6, negative 6. Now, at the lower right-hand corner, I'm going to put a box, and this is where my remainder is going to be. Okay, so let's go down the row. So the first coefficient, I'll bring it straight down. Then 1, we take the coefficient 1, multiplied by the number in the box, negative 2. 1 times negative 2 is negative 2. Now, remember in long division, we subtracted. In synthetic, we're going to add. So net 0 plus negative 2 is negative 2. Then we repeat the process. Negative 2 times negative 2 is positive 4. Negative 7 plus positive 4 is negative 3. Negative 3 times negative 2 is 6. Negative 6 plus 6 is 0. Okay. So what does that mean? Well, if I was writing this using long division, this is basically saying that x plus 2 divided into x cubed plus 0x minus 7 minus 6 will give me a quotient of x squared minus 2x minus 3. So notice my quotient, basically my answer, is 1 degree less than my dividend. Okay. So remember, these numbers are the coefficient of the quotients. Okay. And the quotient, again, is 1 degree less. Now notice, x squared minus 2x minus 3 is a quadratic, and I can further factor this. So x squared minus 2x minus 3 can be further factored into x minus 3, x plus 1. So that means I have, when I divide x plus 2 into x cubed minus 7x minus 6, I get a quotient of x squared minus 2x minus 3, which can be further factored into x minus 3, x plus 1. And this is a good jumping off point for the division algorithm. So when you look at it, don't get confused. All this is saying is that you can rewrite a division problem this way. That f of x, your dividend, which in the above example is x cubed minus 7x minus 6, can be rewritten as a product of factors. So in the above situation, the initial factor that I started off with was x plus 2 times my quotient, which was x squared minus 2x minus 3, which can be further factored into x plus 2 times x minus 3, x plus 1. Okay. Now, if I had a remainder, in which case I do not here, I would do plus whatever the remainder is. But since in this case we didn't have a remainder, we would just eliminate it. So this is just basically by a way of rewriting it. Okay. So let's just summarize before we move on. Okay. So remember in your normal division, so say for example, we're dividing 4 into say 13. Okay. Okay, that will give me 3, 12 with a remainder of 1. So the division algorithm says you can rewrite this as 13 equals my divisor 3 times 4 plus my remainder. Okay, and that's all I did. So x squared minus x cubed minus 7x minus 6 is basically my divisor, which in that case was, I think, x plus 2 times x minus 3, x plus 1, where remember this was my divisor and this was my quotient further factored. Okay. Now, let's do another example. Let's go see x cubed plus 7x minus 2 divided by, say, x plus 3. So remember, we're going to divide by -3, and then the quotients are going to, the coefficients will be 1, 0, because I'm missing the the degree 2 term, 7, negative 2. Okay, so another way to do it is, okay, the number of coefficients that you should have should be 1 more than your degree of your dividend. So if the dividend is 3, I should have 4 coefficients in the top row, which I do. So Again, remember, bring it the first term down, multiply, add, multiply, add, multiply, add. Okay? Just making sure the math is correct. And what does that mean? That means that I can say that x cubed plus 7x minus 2 is equal to x plus 3 times x squared minus 3x plus 16. Remember, this is my dividend. I'm sorry. This is my divisor. And this is my dividend. And since I have a remainder, I will put plus negative 50 or minus 50. Okay. Another way of writing this is saying this. X cubed plus 7x minus 2 equals, divided by x plus 3, because all a fraction is a division problem, equals x squared, can't write today, minus 3x plus 16 minus 50 over x plus 3. So this is an alternate way to use the division algorithm. You can either do it the first way or you can write it the second way. And don't get too caught up about the second way, because all it is basically a mixed number with polynomials. So let's just take a basic situation. 3 into, say, 13 gives me 4, remainder 1. So I can say 13 equals 3 times 4 plus the remainder of 1, or I can say 13 divided by 3 equals 4 plus 1/3, or another way we write this is 4 1/3. So basically all this is mixed numbers using polynomials. All right. So the remainder theorem. The remainder theorem says that whatever the remainder is what that function would be evaluated at that number. So let's go back to my previous example. So when I divided x cubed plus 7x minus 2 by x plus 3, that means that f of negative 3, if I evaluated it, if I plugged it in, I would get negative 50. Okay, and let's see if that works out. So negative 3 cubed, okay, plus 7 times negative 3 minus 2. So negative 3 cubed is negative 27 minus 21 minus 2. And if you do the math, you get negative 50. So the question is, well, why would I ever want to do synthetic division to evaluate a number if I already can just plug it in? Well, if you look at it, and especially if you become more proficient at synthetic division, this is a lot more faster way of evaluating functions. Okay, so let's do an example. Given f of x is equals x cubed minus 4x squared plus 5x plus 3, use the remainder theorem to find f of 2. So we're going to evaluate at 2. So we're going to put 2, we're going to divide by, basically we're dividing by x minus 2. Okay, so we're going to divide by 2. So we're going to write the coefficients. So if it's a cubic, how many coefficients should I expect? It should be 4. Okay. So remember, descending order of power, all powers represented, which in this problem it is. So 1, negative 4, 5, and 3. Okay. Below the last coefficient, you put a box, and that will be your remainder. So we do synthetic division, bring the first number down, then multiply and add. Okay. So my remainder is 5. So what this theorem says is that if I evaluated this function at 2, I would get 5. Okay. And you can plug it in and verify it yourself. Now, this brings up an interesting point. And this is the factor theorem. That if your remainder is 0, then that number is a factor. So remember, what did we say? We said that if we have a solution, we can call it a x-intercept, a factor, a 0, or a root. And so remember, what did I say? If the solution of an equation is x equals a, that means when you plug it in, you get a 0. The x-intercept for that equation is a0, and that x minus a is a factor. Okay, and this is the same thing in math and regular arithmetic. So let's say 24 divided by 3. When we do that, we get 8, and we don't have a remainder. So that's why we say 3 is a factor of 24. So if we have a polynomial and we divide a binomial into it and we get a remainder of 0, we say that that binomial is a factor of the larger polynomial. Okay. So no remainder means it's a factor. And that's basically what we've been doing since we've been dividing. Okay. So let's look at a couple of examples to see how this could be asked. So example 6, solve the equation for 2x cubed minus 3x squared minus 11x plus 6 equals 0, given that 3 is a 0 of the function. Now, we know that 3 is 0. That means my remainder, or my function evaluated at 3, will be 0. And to verify this, we can do synthetic division. And we should expect a remainder of 0. So again, make sure descending in order of power, and no missing powers. Then multiply and add, remembering to bring the first coefficient down unchanged. And you see we got a remainder of 0. Now, what does that mean? Well, because of the division algorithm, that means 2x cubed minus 3x squared minus 11x plus 6 can be rewritten as x minus 3 times. Remember, this quotient is always 1 degree less. So since I started with a cubic, my quotient will be a quadratic. 2x squared plus 3x minus 2. Now, well, what's the significance? Well, if I'm looking for solutions, I'm looking for values of x that give me a 0 as my output. Okay. Well, what does that mean? That means x minus 3 equals 0, and 2x squared plus 3x minus 2 equals 0. Well, how do I solve this? Well, if it's a quadratic, we can try to factor it, and then we're going to talk about the quadratic formula in a second. So the good thing is 2x squared plus 3x minus 2 can be factored. So remember, when the leading coefficient is something other than 1, we have to employ slip and slide. So x minus x plus 4, x minus 1. Now, remember when you're doing simple inside, eventually you have to divide by your leading coefficient and reduce the fractions if possible. And if in this case, in the second case, since it's not reducible, we slide the denominator, hence the name, to the front of the variable. So well, how do I solve the rest of it? Well, just set everything equal to 0 because of the zero rule property, saying that if multiple things multiply to give me 0, one or both are 0. And there are my solutions. So my solutions are x equals 3, -2, 1/2. Okay. So basically, we can use synthetic division and finding factors to fully factorize this entire polynomial. Because when we find the factors, we can rewrite this cubic as a product of 3 factors. X minus 3 times x plus 2 times 2x minus 1 equals 0. And then we set them equal to 0 and solve. Okay. Let's have you guys try checkpoint 6. I recommend you pause the video and then come back when you have an answer that you want to check. All right, so we want to solve this equation. So we want to find a way to factor 15x cubed plus 14x squared minus 3x minus 2. Now, we're given that -1 is a known factor. Okay, -1 is a known factor. So we can use synthetic division. Since we have one factor, we can use synthetic division to find the other factor. So remember, what do I look for before I use synthetic division? Yes, descending order of power and all powers represented. Okay, so we would expect my remainder to be 0. So we bring the first one down unchanged, then multiply and add. Okay. Now, that means this is a quotient whose degree is 2 because the initial dividend was degree 3. So that means this is 15x cubed minus x minus 2. So we can say that f of x equals x plus 1, because if we're dividing by -1, that means the factor is x plus 1 times, oops, not cube, I made a mistake, 15x squared minus x minus 2. So if we're trying to solve it, we're trying to find all the zeros. Of the polynomial. Okay, so how do we solve this guy? Well, since it's a quadratic, we could try factoring. Okay, so remember we do slip and slide, so we get x squared minus x minus 30, which can be further factored into x minus 6, x plus 5. Then we have to divide by the leading coefficient and reduce as much as we can. So 6/15 can be reduced to 6/15 can be reduced to 2/5. And 5/15 can be reduced to 1/3. Slide the denominators in the front of the variable. So we get x plus 1 times 5x minus 2 times 3x plus 1 equals 0. Now, set them all equal to 0 and solve. X equals -1, x equals 2/5, x equals -1/3. And this would be my solution set. Okay, hopefully you got those answers, and make sure you practice some more of these. So take home point. The remainder of a division problem is also what that equation would be evaluated at that number. And if the remainder is 0, it is a factor. Okay. And remember, you can rewrite any division problem as a product of two numbers, plus or minus the remainder. Or we can write it as a mixed number. Now, before we move on to the next section, I want to go back and review with you the quadratic formula. Now, I know on YouTube and all that other stuff that there's songs for it, and that's all nice and well, but the quadratic formula is pretty famous. It's -b plus or minus the square root of b squared minus 4ac over 2a, where a, b, and c are coefficients of the function of the quadratic in standard form. Now, this seems like a pretty involved formula and a lot of stuff to remember, but I like to remember it in pieces. I like saying x equals -b plus or minus the square root of d over 2a. Now, d is pretty significant. It is known as the discriminant. And its formula, obviously, is b squared minus 4ac. Now, it's known as the discriminant because it tells you what type of solution you would expect. It doesn't give you the solution directly. It tells you the characteristic of the solution. So, the discriminant is a number. So, like any number, it can either be less than 0, it can be equal to 0, or it can be more than 0. Now, if it is less than 0, this is a way we could say it is negative, because all negative numbers are less than 0. So if your discriminant is negative, that means you expect two imaginary solutions. Okay, two imaginary solutions. If you have d equals 0, that means that you have one rational solution. So remember, a rational number is a type of real number. A rational number would be like a fraction or a whole number, positive or negative. And moreover, if you have one rational solution, it also means that it is your x-coordinate of your vertex. Okay, so if the discriminant is equal to 0, that means that value of x is the x-coordinate of your vertex. Now, if you want to find the y-coordinate, then you just plug that value of x into the quadratic and you get the y-coordinate. Now, if the discriminant is greater than 0, then there's one of two options. Option 1, the number is a perfect square. That means it is a number like 1, 4, 9, 16, 25, 36, 64, 49, 81, 100, 121, so on. So a perfect square is a number whose square root is a whole number. Now, if it's either a perfect square or not a perfect square. Okay. So if the discriminant is positive and is a perfect square, that means you have two rational solutions. That means the solutions are either going to be fractions or whole numbers, positive or negative. If it's not a perfect square, that means you have two irrational solutions. That means you're going to have like numbers like 1 plus or minus the square root of 2, something like that. That would be an irrational number, a number whose decimals do not repeat or terminate. Something that cannot be written as a fraction, if you will. So the discriminant, the value of the discriminant tells you a lot. Namely, the sign of the discriminant tells you a lot. So if it's less than 0, you're dealing with two imaginary numbers. Remember, numbers with I, square root of negative 1. If the discriminant is equal to 0, that means you have one rational whole number or fraction solution, which is the x-coordinate of the vertex. And if the discriminant is positive and a perfect square, two rational solutions. If it is not a perfect square, but still positive, you have two irrational solutions. Okay. Now, this is pretty significant. That means that all imaginary solutions and all square root solutions like square root of 2, etc., they come in pairs. So that means that if a solution is imaginary or irrational, then the conjugate is also a solution. So what do I mean by that? Well, remember, conjugates are binomials with the same numbers, but in one they're added and in one they're subtracted. So the generic form or the general form of conjugates is a plus b, a minus b. So examples of conjugates: 1 plus root 3, 1 minus root 3. 2 plus I root 7, 2 minus I root 7. Okay. So if you have an imaginary or irrational solution, the quadratic formula says that the conjugate of that imaginary or irrational solution is also a solution. Okay, so they come in pairs. Now, if it's a rational solution, like a fraction or a whole number, it can be solitary. Okay, it doesn't imply anything. But if the solution is imaginary or irrational, its conjugate must also be a solution. So they must be in pairs. Okay, so let's look at an example. Okay, so let's say I want to find the solutions for 3x squared minus 2x plus 5. Okay. The first thing I do is write down my coefficients. Then, step 1, calculate my discriminant. And writing it this way helps me organize my information, so I don't have a bunch of formulas and variables and numbers floating everywhere. So b squared, which is negative 2 squared, minus 4 times a, which is 3, times c, which is 5. Okay. Now I evaluate. -2 squared is 4. Remember, when you square a negative, it becomes a positive. Minus 12 times 5, which is 60. So the discriminant is -55. 56, sorry. Can't subtract this afternoon. Okay, well, what does that mean? Well, since it's negative, what do I expect? Yeah, two imaginary, not irrational. What am I talking about? Two imaginary solutions. Okay. So it doesn't tell me what those solutions are yet. It just tells me to expect two imaginary solutions. Well, let's find it out. X equals -b plus or minus the square root of the discriminant I just calculated over 2a. So plug it in. Negative of -2 plus or minus the square root of the discriminant, which we found to be -56, over 2 times a, which is, so that's 2 plus or minus -56 over 6. Now, remember, we can simplify -56. So the first thing we do is pull out the -1 from underneath the radical. So -1, square root of -1 times 56. Remember, -1 is just I. Square root of -1 is I. So it's I root 56. And we can further simplify 56. Remember, we're looking for, when we simplify radicals, we're looking for two numbers that multiply to give me 56, one of which is a perfect square. So for this situation, what two numbers multiply to give me 56, but where one is a perfect square? So that is 4 and 14, 4 being the perfect square. So 56 can be rewritten as, well, 4 becomes 2, square root of 4 is 2, so 2i root 14. So we found x to be 2 plus or minus 2i root 14 over 6. Now, remember, you cannot simplify this fraction just by doing this. That's not right. If you have multiple terms, numbers that are added or subtracted in the numerator, they must have, and you want to simplify it with the number in the denominator, all the numbers in the numerator and the denominator must have the same factor. So what I like to do is say, okay, what is my common factor? What is the greatest common factor in my numerator? Which in this case is 2. So that leaves me 1 plus or minus I root 14 if I factor out the 2 over 6. Now, what common factor can I reduce both 2 and 6 by? Well, 1. So I mean by 2. So this cancels, this reduces to 3. So my answer is 1 plus or minus I root 14 over 3. So my solutions are 1 plus I root 14 over 3 and 1 minus I root 14 over 3. So if you see, they're the same numbers, but one is, in one they're added and one they're subtracted. So these are conjugates. Okay? And I expected that because my discriminant is negative. That means I expect two imaginary solutions. And remember, we said this, that if the solution is imaginary, we expect the conjugates, the number and its conjugate to be a solution. Okay, so this is where I'm going to close the lecture off for this section. And I'm going to there's going to be another lecture that's going to pick up with 3.4, which talks about the rational root theorem and Descartes rule of signs. If you have any questions, please feel free to email me or send me a remind. Make sure you are in my remind group, and I will talk with you later. Thank you.